Hello the internet and welcome back to my channel. Today we're gonna work on the Ask motherboard again. After my last video I couldn't fix the cache. I've got some replacements, so bear with me, we're gonna try and fix it today. Also, I'd like to give you a sneak peek of what's coming over on my channel over the next months. But most importantly, I'd like to say something again. Now, I know on my last video, I announced that my channel had reached 1,000 subscribers. It was a big thing for me. I'm not a full-time YouTuber, as you might have noticed. So that was a big goal, to be honest. Now, I don't know exactly what happened. Yes, my last video maybe was quite interesting, lots of faults on the motherboard, but this channel has moved in just a few weeks' time from 100 to 150 views a day to 4,000 views a day. And right now, today, at the time of shooting, this channel has around 3,100 subscribers. I mean, it's completely crazy. I was totally not expecting it. I'm totally flabbergasted. I've been flooded by incredibly positive comments from you. Thank you so much. I honestly, I'm speechless. I don't know what to say. I was totally not expecting this. That being said, before we move on with the motherboard, because I'm going to be a bit busy over the next few weeks for work, I just like to give you a sneak peek of what's coming, just to let you know that Tony's 359's Tinkering Shop is alive and this is what's coming. You see behind me some PlayStations which I'm going to play with. I have another motherboard which I need to take a look and see what's wrong with it. And most importantly, at least from my point of view, I have this little guy which is in need of attention. This is my first Macintosh, so it's going to be interesting to see what's happening. Now let's crack on with the motherboard, and in order to do so, I've received something from one of my viewers. I've received the spare parts I need. So let's take a look what's inside this bag and see if we can fix that motherboard. Okay, let's take a look what's inside this envelope. First of all, let me say this is the first time that someone is sending me something. I don't really know what to say, to be honest. Again, I know that some YouTubers are used to this, but I'm not. So this is my very first time. This is coming from the US, from user Sphere478 from Vogons.org. Sphere was kind enough to send me basically a whole set of cache from one of his motherboards, and he said he also sent me some of his projects. So let's take a look. Right, this is one of Sphere's interesting projects. It's called the Voltage Interceptor, and it's for socket 5, 7 and super socket 7. Now, if I understand this correctly, this is for like overclocking or setting different frequencies, multipliers, tweaking, all that you can tweak from one processor. But, you know, normally you would have to, I don't know, like add a pull up resistor or pull down resistor. You have to solder something at the back of the processor. The thing is, sometimes you need to disconnect some pins from the motherboard, so that becomes a bit complicated, obviously. And this is apparently it's a very neat tool. So it's made up of these two parts. So this bottom part goes into the motherboard socket. If I understand correctly, the CPU goes here. Now, I'm not going to push this all the way down because this processor has some not bent pin, but not totally straight one, so I don't want to damage it. And you have a number of settings here at the back, so a number of pads where you can add pull up, pull down resistors, or lots of stuff. I need to look into the documentation to understand what you can do with all these things. You have some pins which have been circled here on the PCB, which have been removed from these, let's call it the interposer. So what's happening, when you put this back in, like this, then you can fit this into the motherboard. The heatsink will fit on the PCB here, and suddenly you have all the tweaks applied that you need, and you have also access to VCC2, VCC3 and ground on these large pads, which means you can use an external power supply as powerful as you want, as clean as you want, if you feel your motherboard doesn't have a power supply good enough for this thing. This is pretty ingenious, pretty neat. I'm assuming that with something like this, you can do all the tweaks that you want in a very elegant way. That's pretty interesting. Thank you, Sphere, for sending me this. Obviously, I'm linking down below in the description the website. Well, it's rather than a website, it's a Vogon discussion where you can see all these projects. Thank you, Sphere. This is a piece of art. The Voltage Interceptor comes with some dip switches. This is basically to set all the features that you might want to have from this modification. So I thought I should solder them on, or I'll just lose them within 24 hours. Now, besides this, under this cover here, we have a whole new chipset from a TX motherboard. So we can check online in a second what these are, but these are supposed to be compatible with my motherboard. Let's take a look. Right, here it is. The chip is a T35L6432A. It's a synchronous burst RAM, and yeah, that looks like what we need. What I'd like to do now, as many of my viewers have recommended, is to double check that the ground and VCC are correct on my motherboard, which should be. Again, the chips on my motherboard are the 6432 series, so it should be compatible, but I guess it's a good idea. I've got the multimeter set for continuity. On screen you can see the pinout, which I have rotated because right now, well, yes, I could have rotated the motherboard, but no, this is convenient so I can have the multimeter side by side, because the pin 1 of the existing cast chip is here. So let's check for VCC first. I've got my probe on VCC, and the VCC here is supposed to be, it's number 15. Okay, we got it. Then we have VSS, which is ground on number 17. And we got it. Up there we have VSS on 40, so this is 31. There you go. And the next one is supposed to be VCC. And it is. Finally, we have VCC on 65. There you go. And 2 afterwards is ground. Yes. Perfect. We got the VCC and ground, which are totally matching. So the tag RAM is an AE58256AJ. Unfortunately, I can't find the data sheet for this one, but this is looks like it's the standard. This is, first of all, it's 5 volts, it's not 3, but I can see the supply is opposite pin 1, which is pretty typical. And ground is on the opposite side, which is again pretty typical. I don't know, I'd be maybe tempted, maybe I can leave this in place and see if by any chance it works. I doubt this is gonna cause any damage or anything, and if it doesn't work, then I can still replace it at the second stage and see what happens. I'm going to clean these cast chips. There's a little few bridges, solder bridges, which is totally normal when you desolder something. I noticed that thing while I was editing the video, and I thought I had removed a whole trace from the motherboard. So I went double checking and I couldn't see anything wrong. So looking at the video, it looks like the molten solder just made that weird shape while I was removing the chip. Okay, the board is prepared, the chips are prepared, and I'm ready to do the soldering. So I have this tiny soldering tip, which would be perfect for this kind of work. Besides, I'm using a way too big solder wire, which I was going to swap in a second. But the thing is, I've always had trouble using it because it looks like it doesn't have enough thermal mass to actually do anything, as you can see here. So at some point I thought, you know what, maybe I just need to crank up the temperature on the station, because the thing is the station will probably not give you a reliable temperature because the tip is too small, and I guess the temperature sensor is buried inside the heating element. So once I've done that, it actually started working decently, as you can see here, until I reached these two pads which look like have a thicker trace underneath, and that's where the tip became useless again. It can't do anything. It's unable to reflow anything. So reluctantly, I had to go back to my larger tip, which is still small enough to do the job. But yeah, I've been having that problem all the time, and I'm wondering whether either my station is not good enough or the tip is not good enough. The tip is a hacker one, the station is not, but as you can see, the larger tip is able to do the job nicely. And the chips are back in. Now let's repopulate everything and let's give this a test. Right, this is the moment of truth. Will it work?
No.
Let's try it out.
Don't,
3,
what are you
2,
doing? Don't
1,
power up.
Go.
Don't power up.
Ooh. How did I do that? How did I even do that? I didn't even know if it fit. Okay, that's not good. Oh, come on, Tony. Let's try this again. Silly me. 3, 2, 1, go. Ooh, okay, let's put it up. Never again, please. I need to mark that thing somehow. Okay, it is booting up. The cast chips are normal temperature. I'm going to check that the cache is enabled. External cache is enabled. Perfect. Save and exit. And finger crossed. Yes! Pipeline burst. Yay! Cache memory 412. Yes! That's so cool. It's a bit fuzzy, but you can see 512 kilobyte of L2 cache, 185 megabyte per second. That's absolutely fantastic. I love this. Now let's do a couple of benchmarks, but first I have to replace the CPU because this is my Pentium 200 MHz, and in my last video I had my 90 MHz. So let me replace the CPU and rerun some benchmarks. Pentium 90 is in. Let's run the benchmarks. As usual with benchmarks, results can vary a lot. We go from a very good 19.3% improvement with PC Player benchmark to a much less exciting 1.9% with 3D Bench. Doom is getting a 6.7 uplift, I guess is probably making use of the cache, while Landmark Speed Test is a tie, assuming it's not using the cache at all. Top Bench is more or less a tie as well, with 0.4% improvement, as is Spitzes. Now Quake is going back to a good 10% improvement compared to no cache, and Chris's benchmark is only getting a 1.4% improvement. Now, one very last thing to do, which some of you noticed and commented under my video, is basically to replace this smashed inductor. Even though that seems to be working, but the thing is, it's an inductor. It means that probably the voltage is not going to be as smooth as it should be. So it makes sense to replace it. So I've been asking online, Vogons as usual, and it looks like there are a few ways. Apparently the color of the core is telling you what material it is. Then you want to count the turns and the wire gauge to basically calculate the value of the inductor. One other way, which I think it's probably the laziest one, which I'm definitely going to do, is to remove a working one and use my little component tester to check the inductance of this thing, which I didn't recall that it would measure it. So I've got my desoldering gun warming up. I'm going to remove this one and we're going to measure the value of this one. No, it doesn't look like it's measuring the inductance unless I'm doing something wrong. It's only measuring more or less a short. So I guess we'll have to go with count the number of turns and do the calculations. Now, and unfortunately, none of my meters here are reading anything when set to the capacitance. That's a neat trick from Dave at EEV Block, but neither my X-Tech, which needs some attention, reads any capacitance, nor my Fluke is reading anything. So I will have to do a little math. I need to calculate manually that value and see if I can source a replacement. So by doing a little calculation, given the diameter, the number of turns, and the size of the wire, this looks to be something around 80 microhenry, which is the unit of measure of inductance. I can find something reasonably close to RS components, but obviously it's not going to be cheap. And to be honest, I don't want to spend like 15 pounds in inductors on this board. eBay's hit and miss as usual. I can't find exactly 80 something. I can find like 100 microhenry. So I need to check whether that's going to work or not for this motherboard. Let me say this. I mean, the inductor that we have, the broken one, clearly works-ish. I've set up a search on eBay, so I will get notification whenever I get something which suits my need. For now, I think I can put this back and live with the broken one until I get something which is not costing an arm and a leg. And just very briefly, what is an inductor doing on this board? The inductor is usually found after a switching mode power supply. I've been calling the switching mode power supply. I think the actual name is a buck converter. So you get DC in and you get a different DC out. But the principle of operation is the same as switching mode power supply. A linear, for example, voltage regulator works. You go voltage in, voltage out. And that's it. You got something which is immediately usable. It's very smooth. It's perfect. But those are not very efficient. They heat up quite a lot. They require heatsink, and obviously they dissipate quite a lot of energy. By using these switching operations, it is so much more efficient because this thing usually don't get very hot. So the way it works, these two transistors, MOSFETs actually, they will like chop the voltage. So say, for example, you have 5 volts in or 12 volts in, and you want 3.3 out, which goes to the CPU. Rather than regulate the voltage from whatever you have in to the 3.3 out, you basically switch the voltage on and off, on and off, on and off, until as an average, you get the 3.3 that you're looking for. Now, you can't feed these switched voltage to anything, because it's, yes, on an average it's 3.3, but it's not going to work not with the CPU. So you need to smoothen it up. And one way to smoothen up voltages is definitely capacitors, which, as you can see, you have them here. But another way is to use an inductor. So an inductor, not that I know these things, but the way I understand they work, basically the current flows through these turns. It generates a magnetic field which basically counteracts any variation in the voltage itself. So see it like a device which smoothens up all those slices of voltage, if you want to call it that way. If the inductor is broken like this one, well, I'm assuming the output after the inductor is going to be not as smooth as you would expect, which, again, for a CPU could be a big deal. And I've just realized something which I feel is worth mentioning. So I've got my probe here in the 5 volts coming from the power supply, and it looks like that this inductor is on the 5 volts line, which then eventually goes as an input of this transistor, which is generating the 3.3 volts for the cache modules, and for the I/O of the CPU. Correct me if I'm mistaken, but that is making this inductor so much less important, because the voltage coming from the power supply is already filtered. It's not coming straight from a buck converter or from a MOSFET, where obviously it has to be smoothened up. If I see this right, I'm not saying I don't want to replace this, but that's probably why the board has been working with this completely smashed. So this is it. The motherboard is fully functional. It's really rewarding feeling to know that the motherboard is 100% working. Hopefully you watched the previous video and you know how faulty this motherboard was. So having been able to fix everything 100% is absolutely amazing. It's a great feeling, for which I have to thank Sphere for sending me the replacement cache modules, but also for sending me this very nice little tool, which I'm planning to have a look at some point in the future. Well, what's left to be said? Well, thanks again for all your fantastic comments and feedback on my videos. Thanks for all the new subscribers, all the views. It's an amazing feeling, and I'm so looking forward to my next videos and our next adventures together here on my channel. If you like this video, please hit the like button below and consider subscribing if you like what I'm doing. For now, as usual, you have a great day, and I hope to see you soon again here on my channel. Goodbye for now.